Hi, this video is about free fall with objects moving up and down. Imagine someone launching a ball straight upward at, let's say, 30 meters per second. Find the position and the velocity of that ball at 4 seconds. That's our goal today. Now, in our class, it's safe to assume that the object is in free fall. That means no air drag and only gravity is acting on the object, unless it's stated somewhere in the problem that it's otherwise, like there is air drag or it has a rocket motor or something like that. So we'll assume that this ball, which is launched upward, even when it's moving upward, it's only under the influence of gravity, and therefore it's in free fall. Let's think about this graphically. We'll do it with a motion diagram. And so I have the ground down here. We'll call that position 0. And we'll start down here on the ground at 0 seconds. And then at 1 second, it's gone upward. At 2 seconds, upward again, but it's slowing. So you notice I put these dots closer together than between 0 and 1. And then at 3 seconds, and then eventually it starts coming back down on the other side. How did I know to draw the top at 3 seconds? That's a good question. Well, I know that g, that is free fall acceleration, is 10 meters per second squared. And in this frame of moving up and down, we have to be very careful about choosing what positive means and what negative means. So let's say that up is positive, and let's say that down is negative. And if that's the case, remember acceleration is a vector, then the acceleration here is negative 10 meters per second squared, because it's accelerating downward, even when it's moving upward. So after 1 second, it's no longer going to be going 30 meters per second. It's going to lose some speed. In fact, it should be going about 20 meters per second here at 1 second, because every second that goes by, it loses 10 meters per second. That's what that acceleration means. At 2 seconds, it will have lost another 10 meters per second, so down to 10 meters per second. Still up. And then at 3 seconds, it will have lost its last 10 meters per second, so it's 0 meters per second at the top. But once it reaches the top, it's not done. It begins to fall back down. And so at 4 seconds, it'll change from 0, and now it'll gain 10 meters per second in speed, but it's down. So I'm going to put a negative sign, 10 meters per second. And then another second later, it gains 10 more. And finally back down here at the bottom, when it hits the ground, when it strikes the ground, it would be going negative 30 meters per second down there at the bottom. So if it's launched up at 30 meters per second, it'll take about 3 seconds for it to slow all the way down to 0 at the top, and then 3 more seconds for it to fall back down. Our question today is what is its velocity and its position at 4 seconds? Well, our kind of analysis right here already told us the velocity. It's moving 10 meters per second down. So that's one way to approach it. But we can also approach the velocity another way. We can approach it algebraically and using our guess method. So what's the final velocity? Well, what we're given in the problem is the original velocity is plus 30 meters per second. The acceleration is g, negative 10 meters per second squared. Very important to keep those signs appropriate, whether it's moving up or down. And then the time is 4 seconds. We need to find the final velocity. It would be nice if we had an equation that had VO, A, T, and VF in it. And if you look on your cards, you'll find one, this one, the acceleration equation. And so I write that equation down under E. I substitute my values in for A and VO and the time. And then in the last step, I solve the equation. And when you do that, you get the same answer that we got using the motion diagram and just thinking about it in terms of acceleration. So we get negative 10 meters per second, which means 10 meters per second down in this case. What about the distance? What about the position of the object? Well, for that, we can think algebraically again, except this time we're looking for x. We're looking for the position of that. We know it's above the ground, so that position should be positive. Remember, we called the ground 0. So that position is above the ground, so it should be positive. But what is it? So the original velocity I've written down again under givens and unknowns, and the acceleration, and the time, but in this case, we're looking for x. And so I need an equation that has those 4 things in it, and I found this one on the toolbox on your equation card. And then I substituted the values in. And then I began solving. So 30 times 4 is 120. Half of negative 10 is negative 5. And 4 squared is 16. And then 5 times 16 is 80. But it's negative because there's a negative sign on the acceleration. So it's 120 minus 80, which gives us 40 meters. So it's 40 meters above the ground. We could do this another way. Since we found out the final velocity on the previous slide, oops, thought I was going to get by without this falling on me, but maybe not. Since we found the final velocity on the previous slide, we could use that information. Now, it's probably better if we can avoid using this, to avoid using it, but sometimes this is the first way that pops into your mind. You calculated that and you're pretty confident in that. We looked at that 2 different cases. You can go ahead and use it if that's the way you think about it first. No problem with that. So under givens and unknowns, I know original velocity, acceleration, time, and final velocity because we calculated that and we looked at it graphically. And so I could use 2 equations and solve it that way. I could first find the average velocity. So the original is 30 meters per second positive, and the final is negative 10. And so the average of 30 and negative 10, the addition of 30 and negative 10 is 20, and 20 divided by 2 is positive 10. So the average velocity from 0 to 4 seconds is positive 10 meters per second. And then I can use the other equation for average velocity and find the displacement. So the average velocity I took from here and plugged it in there, and the time is 4 seconds, and 4 times 10, of course, is 40. And so we get 40 meters above the ground as well.